Okay, so here is the formula based on what we saw on the previous page, that the 1/2, you can pull it out of the formula and put it in front of the integral. And s squared ds this time, s is a leg in the region. And so based on everything I looked at from College Board, it seems like every time they talk about isosceles triangles, a leg is in the region. So this next example has a graph that comes with it. So we have y equals 4 cosine pi x over 4 and x minus 2 squared. So again, it says that region is a base of solid. For the solid, each cross section perpendicular to the x-axis is a right isosceles triangle with a with a leg in region R. So again, we're drawing our slices so they are perpendicular to the x-axis. And this time we can use what we did a couple lessons ago, where we will need to do top y minus bottom y because it doesn't go all the way down to the x-axis. So if I were to draw the slice over here, my top y would be the 4 cosine pi x over 4. My bottom y would be x minus 2. So let's go ahead and use the formula. This time s is top y minus bottom y. So we can go ahead and start plugging into the formula. We have a 1/2 integral. We're using the x values, so we're going from 0 to 2. Those are my boundaries. And I'm going to take s and square it. And dx, recall, is the width of my cross section, how wide this triangle is. So fortunately for this, we can use a graphing calculator. So let's go ahead and practice plugging in. Again, with some fractions, I prefer to just use alpha y equals from 0 to 2. And you notice that this already has parentheses. However, we need another set of parentheses so that we can square all of it. So go ahead, add in a parenthesis. 4 cosine, and I'll use the fraction here, pi x over 4. Go ahead and close that parenthesis, that argument for cosine, minus, and then we're going to start x minus 2 squared, and then go ahead and close the parenthesis that we used here and go ahead and square it there. So you should have a lot of parentheses and squares here all together. And remember to round to the first 3 decimal spots, so we have answer A. Alright, I would like you again to pause the video, go ahead and try example 6 on your own, and when you click play, I will go over it. Alright, so again, in this one, we have a region where we have this polynomial curve, and the horizontal line y equals 4. And then f of x is this curve down below. So again, my cross sections are perpendicular to the x-axis. That's isosceles right triangle with a leg in R, and f of x is down here. So again, if I use this formula, up at the top of your paper, s will be the height of this cross section. So again, I need to use top y minus bottom y. So here my top y is 4, my bottom y is f of x. And recall that if a function is already named, College Board will allow you to use it again, so you can save, 2 seconds of writing on the College Board test. Instead of writing all this, you can just write this. And by the way, this is a free response question. So So let's go ahead and use the formula. 1/2. Here, we don't know the intersection points. Well, I suppose we know this one. But to get this other one, you would go ahead and plug into your graphing calculator. You should get 2.3, 4. So we're going from 0 up to 2.3. Remember, we're doing everything in terms of x because it's perpendicular to the x-axis. So that's why it's 2.3. And again, I'm going to take s. So it's 4 minus f of x. And I'm going to square it, dx. Let's go ahead and plug this into our calculator. So we'll go from 0 up to 2.3. Again, go ahead and put in a set of parentheses because we're going to need to square it inside the set of parentheses that the calculator already gives for you. So here, please be careful when you actually type out x to the 4th and 2.3x cubed and 4. We do need to subtract everything. So imagine putting a subtraction symbol and parentheses around all that. You need to distribute the negative over, so it's going to change the sign of everything. So we're going to have a minus x to the 4th, a positive 2.3x to the 3rd, and a minus 4. .574 if you round. So like I said, this was a piece of a free response question. So this one was actually worth 3 points. 2 points was for your integrand. And 1 point was for the answer. Our last topic for this last lesson is semicircles. So again, we're going to go ahead and try to set up the semicircles using y equals x. So our region is y equals x from 0 to 4. And so this time when we draw our cross sections, they're perpendicular to the x-axis and they are semicircles. So here is my cross section. If I were to pull this out, similar to the book in the bookcase, now my books would be semicircles. So go ahead and draw a semicircle, and then behind it, draw a line sticking out, and then just go ahead and curve on the way back. Obviously, this is not a great semicircle, but I hope you get the idea. It will look something like this. So, how tall is this semicircle? In other words, the diameter, it's x. So the whole piece is x. The thickness of the semicircle, again, is dx. So if it helps to see that this piece here is this back piece of the semicircle. So you can imagine, hopefully, that this is curved, sticking out, and what we have here is a piece of it. So now we would need to find the area. So again, I'm just going to look at the face, 2D object to find area. And so area of a semicircular circle, which I showed in the warm-up, was 1/2 pi r squared. So this time my radius is going to be 1/2 x. It's half of the full x diameter. So let's go ahead and plug in 1/2 x, and then you square that. So if you apply the square to each term in the product, you'll get 1/4 x squared. Multiplying it all out, you get 1/8 pi x squared. And so in order to find the volume, you would multiply times dx. In order to add up all these cross sections, you would go ahead and integrate. So we would have from 0 to 4 as the boundaries were given by the problem, and 1/8 pi x squared dx. So if you want to pause for a minute, plug it into your calculator, your answer should be 8.378. And this leads us to the formula for semicircles. So if it's a semicircle, it's going to be 1/8 pi. You can just pull that constant out. R squared dr, where r is the radius. So please be careful. You're going to have to take half every time in order for a semicircle, because what's given is a diameter. So you need to take half in order to find the diameter. I'm sorry, in order to find the radius. If College Board asks for a quarter circle, then a quarter circle is just half a semicircle. So to take half of 1/8, you would get 1/16. Very similar formula. Okay, let's go ahead and do one example together. So this time we have y equals 2 x-axis and 0 to 1. So this is the region that I'm looking at. The solid, each cross-section perpendicular to the x-axis is a quarter circle with the corresponding circle center on the x-axis and one radius in the xy plane. Whew, okay, what on earth does that mean? That means that the center of your circle is here because it's a quarter circle. So last time the center was sort of up here in the middle. This time the center is on the x-axis and one of the radius is in the xy plane. So this is the xy plane, the piece of paper. So we'll go ahead and use the formula for quarter circle. And because this is a quarter circle, this time you will have this as your full radius. And so you will have 1/16 pi integral from 0 to 1 2x squared. So again, make sure to put parentheses around that so you know to square all of it. Dx. And if you were to square this, you would get 4x squared dx. Integrating this, you would get 4. You would need a x cubed, and then you would need to divide by 3 in order to take care of that 3. There's no 3 that shows up in your integrand from 0 to 1. Go ahead and just plug in 1 because when you plug in 0, nothing will come of that. And when you multiply everything out, you should get 4 pi over 12, and go ahead and reduce that to pi over 3, which is letter C. Okay, earlier, I believe I may have misspoken when I said semicircles. You have to be careful with the radius, but if you'll notice back up here, the way we constructed the formula, we already took half of the x value. So you'll notice x is literally the diameter. So it just depends on whether you have a semicircle or a quarter circle. So go ahead, pause the video, try example 9, and then when you click play, I will go over it. Alright, so we have, in the first quadrant, we have x squared between 0 and 1. So this time, the cross-section perpendicular is a semicircle. So again, when we use this formula and we have the radius would be half of this, but I believe this should be more of the height of the whole entire semicircle, so in other words, the diameter. And In the quarter circle case, this is the radius, so I apologize about that. It should be more of the diameter. There we go. So down here, we have the formula, 1 over 8 pi. We are going from 0 to 1. Here, my diameter is x squared. It is the full length, and then you want to square that. And again, we're going to do this by hand. You'll notice it does not say to use a graphing calculator. When you square an x squared, you get x to the 4th. The antiderivative of x to the 4th is x to the 5th over 5. So when you plug in 1, you get 1/5, and then when you plug in 0, it's nothing. So you end up with pi over 40. And there you have it. Let me just show you some examples of what this is looking like. So in your textbook on page 416, there is an example of equilateral triangles. So it would look something like this. Your books on your bookcase would be equilateral triangles. For the right isosceles books on your bookcase, it would look something like this. And then for the semicircles, it would look something like this. Right here on page 412, you can see what that would look like.